Welcome back to All This Math. This is Professor Parker. Make sure you're subscribed to the All This Math YouTube channel. Make sure you drop a comment down below. Make sure you like this video. Make sure you share this video with somebody else. All right. Now, what we're doing today is we're dealing with some sample Keystone Algebra 1 questions. What is the Keystone Algebra 1? Keystone Algebra 1 is a standardized test that students in the state of Pennsylvania will take. All right. To demonstrate their level of understanding of Algebra 1 concepts, pretty much. But these concepts that you'll find on the Keystone Algebra 1 will very likely be found on standardized tests in other states in the United States. All right. So let's look at this problem. It says, which expression can be simplified to x root 3, root meaning square root, x root 3, or x times the square root of 3, where x is an integer. What's an integer? Make sure you know what an integer is. All right, an integer is a number, basically. I'll give you an example. No decimal, no fraction parts. No decimal or fraction parts, right? That's an integer, okay? So 2.2 is not an integer because of the 0.2 part. 1/2 is not an integer. It's a fraction. Now, 3 over 1, or let's see, 4 over 2, 4/2 is an integer because you can simplify it to just plain 2, right? In simplified form is what we're talking about. So if you have a fraction that's not in simplified form, if you were to simplify it and ended up with a whole number, right, or an integer, you can end up with an integer, right? So like 4/2, that looks like a fraction. But what if you simplify it? You actually do 4 divided by 2, you end up with 2. All right, so 2 is an integer. So 4/2 is simplified to 2. All right, so where x will be an integer. So what they're saying is, which of these 4 expressions, these multiple choice options, root 48, root 51, root 54, root 57, which of these can equal a number times root 3? So what we're doing is, what you need to know how to do in order to do a problem like this, you need to know how to simplify radicals or simplify radical expressions. See, expression, these are expressions, right? Simplify radical expressions. Now, what happens when you simplify a radical expression? When you simplify a radical expression, what tends to happen is this. First, let's look at what happens when you have a perfect square inside of a radical. So let's say you have the square root of 9. 9 is a perfect square because 3 times 3 equals 9. So the square root of 9 is equal to 3, right? That doesn't really need to be what we wouldn't undergo the method that I call simplifying radicals, right? But what happens when you have a number that's not a perfect square, but it does have a factor that's a perfect square? And we're not talking about 1 either, right? Because 1 is a factor of everything, right? So like, for example, what if we had the square root of 8, right? 8 is not a perfect square, but 8 has a factor that is a perfect square. So you could basically simplify 8 and call it 4 times 2. And when you call it 4 times 2, now the 4, which is a perfect square, comes out of the radical sign and becomes a 2, right? When it comes out, it's not a 4 anymore. It's a 2. So now you have 2 root 2, right? This is the integer 2, right? Then you have a number inside the radical or the radicand. It's set up like this, right? So what they're looking for is, which of these answer choices can be simplified, right, in a way where you have an integer outside, like this 2 is, and you have root 3 on the inside. All right, root 3 on the inside. So let's go through these step by step. Let's look at choice A. Choice A is root 48. All right, now the first question, is 48 a perfect square? The answer is no, it's not. There's no whole number that can be multiplied by itself that will equal 48. All right, 49 is a perfect square because 7 times 7 is 49. Before that, you got 36 because 6 times 6 is 36. 48 is in between 36 and 49. Therefore, that's another reason that you know 48 is not a perfect square. But 48 does have, actually, it's got a couple, but it's got factors that are perfect squares. But you want to deal with the one that's the largest. You want to deal with the largest perfect square factor, not the smaller one. You want to deal with the larger one. All right, so this is going to become 16 times 3. Why 16 times 3? because 16 is a perfect square. Now, somebody looking at this problem might say, well, why you didn't do 4 times 12, right? Now, the reason I didn't do 4 times 12 is because even though 4 is a perfect square, just like 16 is, if you do 4 times 12, you still have a 12 inside the radical sign. You still have a 12. And if you have a 12, then you still have to break the 12 down because 12 has a perfect square factor. So basically, if you don't pick the largest perfect square factor, you're going to have to do this step multiple times, maybe twice, maybe 3 times. But if you pick the largest perfect square factor, you only have to do the step 1 time. So that's why. That's why we use 16 times 3, and we don't use the factor pair 16 times 3. We don't use the factor pair 4 times 12. Again, because if we use 4 times 12, we're going to have to do the step over again. And it's more efficient to just do the step 1 time. So if we got 16 times 3, 16 comes out of the radical and becomes a 4, leaving us with 4 root 3. So we got 4 root 3, right? Now, this should be our answer because it says which expression can be simplified to x root 3 where x is an integer. So basically an integer times root 3. 4 is an integer. This is times root 3, right? B is wrong because B doesn't have a perfect square factor. So B can't be simplified that way. 51 doesn't have a perfect square factor except for 1. 54 would be, you can simplify 54 to 9 times 6. Since we know our multiplication facts, we know that 9 times 6 equals 54. We could do 9 times 6, then the 9 would come out. When it comes out, it's a 3. So then we'd have 3 root 6. But we're looking for a 3 inside the radical sign. Now, there's an integer outside, but we would need there to be a 3 inside the radical and not a 6. That's why C is wrong. And then with 57, 57 doesn't have a perfect square factor besides 1, right? Just like 51. 51 doesn't have a perfect square factor besides 1. All right, so that's why D is wrong. So the correct answer is A. And again, for this type of problem, what you really need to know how to do is how to simplify radical expressions, right? When you're radicand, that's the number inside the radical or the expression inside the radical sign. In this case, 48 is not a perfect square, but it does have a perfect square factor. So you could break it down like we did here. We broke the 48 down into 16 times 3. And then the 16 comes out and turns into a 4. And then we have the 3 still left inside the radical sign, right? Notice, again, let me reiterate this because it's very important. I didn't do 4 times 12. Why didn't I do 4 times 12? Because even though 4 is a perfect square that we could have factored out, or not factored out, but simplified and turned into a 2, because the square root of 4 is 2, that 12 that would have been left in here, we would have had to still simplify to 12. So that means we end up doing doing the process over again, doing it in 2 steps instead of doing it in 1. If you pick the biggest perfect square factor, you only got to do the step 1 time. All right. So that's another type of example of a question you might see on the Keystone Algebra 1 exam, the standardized test. And it's not just for Pennsylvania. You might see this type of question on a standardized test for any of the states. All right. Make sure you subscribe to the All This Math channel. Make sure you drop a comment down below. Make sure you like the video. Make sure you share the video with some other people. I'll see you all on the next video.